Hey everyone! Welcome back to Zain Facts Channel. Today we're diving deep into one of the most fascinating topics in science, the origins of the universe and the Big Bang Theory. We're going to break it all down into bite-sized, easy-to-understand segments, and along the way we'll sprinkle in some fun examples and interesting facts that will make this cosmic journey unforgettable. So grab your space helmets and let's blast off. What is the Big Bang Theory? First off, let's clear up what the Big Bang Theory is. And no, I'm not talking about the TV show with Sheldon and his quirky friends. The Big Bang Theory is the leading explanation about how the universe began. Think of the universe as a giant balloon. Right now it's inflated, but it all started as a tiny, compact balloon with all the matter and energy of the universe squished into a point smaller than a pinhead. This point was incredibly hot and dense. About 13.8 billion years ago, this point started expanding, and it's been growing ever since. The Big Bang Theory isn't just a concept, it's a journey back in time to the very beginning of everything we know. Imagine for a moment that you could shrink down to the size of an atom and witness the birth of the universe. What would you see? The singularity and initial expansion. The story starts with a singularity, a point where all the mass and energy of the universe were concentrated. This point was incredibly hot and dense, so hot that the laws of physics as we know them break down. Think of it as a cosmic pressure cooker where everything is squeezed into an unimaginably small space. Around 13.8 billion years ago, this singularity began to expand. But don't think of it as an explosion in space, rather it was an explosion of space. This expansion happened everywhere at once, like the dough of a raisin bread rising with raisins spreading apart. Inflationary epoch. For the first tiny fraction of a second, the universe underwent an incredible period of inflation, expanding exponentially faster than the speed of light. Imagine blowing up a balloon so fast that it goes from the size of a marble to the size of a galaxy in an instant. This inflation smoothed out the universe, making it more uniform and setting the stage for the formation of galaxies and other structures. After inflation, the universe was still extremely hot, but it started to cool down as it expanded. During this phase, particles began to form, and the universe was a hot, dense plasma. Think of it as a giant, glowing soup of particles. Interesting facts. 1. The cosmic microwave background, or CMB, is the afterglow of the Big Bang, filling the entire universe with a faint glow. Discovered accidentally by Arno Penzias and Robert Wilson in 1965, it's like a time capsule that provides a snapshot of the universe when it was just 380,000 years old. The CMB is incredibly uniform but has tiny fluctuations that give us clues about the early universe's structure. 2. The expansion of the universe. Edwin Hubble's observations in the 1920s showed that galaxies are moving away from us, and the farther they are, the faster they're moving. This led to the realization that the universe is expanding. This expansion means that if you trace the movement of galaxies backward in time, they all converge to a single point, which supports the Big Bang Theory. Hubble's discovery was like finding the breadcrumbs leading back to the beginning of time. The birth of matter. Right after the Big Bang, the universe was in a state of extreme chaos. It was so hot that particles we know today couldn't exist in a stable form. But as the universe expanded, it started to cool down, allowing these particles to form. Quark-gluon plasma. In the very first moments, the universe was a seething soup of quarks and gluons. Gluons are particles that act as the glue holding quarks together to form protons and neutrons. This quark-gluon plasma was so hot and dense that it was impossible for quarks to bind together immediately. Imagine trying to hold hands in a crowded, boiling, hot dance floor where everyone is moving frantically. As the universe continued to expand and cool, quarks began to combine into protons and neutrons within microseconds. This process is akin to ingredients in a hot soup coming together as the soup cools down. Nucleosynthesis, the first elements. A few minutes after the Big Bang, the universe cooled enough for protons and neutrons to start combining into nuclei. This process, known as nucleosynthesis, led to the formation of the lightest elements, primarily hydrogen and helium, along with trace amounts of lithium. This all happened within the first 3 minutes. Imagine a cosmic kitchen where the chef, the universe, quickly whips up the first ingredients needed for all the recipes to come. Interesting facts. For a brief moment, the universe existed as a quark-gluon plasma, a state of matter that we can now recreate in particle accelerators like the Large Hadron Collider, LHC. Studying this quark soup helps scientists understand the conditions of the early universe. The light elements formed during nucleosynthesis are still present today and are the most abundant elements in the universe. Hydrogen makes up about 74% of the universe's baryonic mass, while helium accounts for about 24%. The formation of galaxies. After a few hundred million years, the universe had cooled enough for the first atoms to form, marking the end of the cosmic dark ages. The stage was set for the formation of stars and galaxies. The first stars, population 3 stars. The first stars to form, known as population 3 stars, were composed almost entirely of hydrogen and helium. These stars were massive, hot, and short-lived, burning through their fuel quickly and ending in spectacular supernova explosions. These explosions scattered heavier elements into space, seeding the next generation of stars. Galaxy formation. Gravity pulled hydrogen and helium gas into denser regions, forming the first stars and galaxies. Over time, these stars grouped together to form galaxies, the building blocks of the universe. Imagine the universe playing a giant game of cosmic Lego, where these stars are the blocks coming together to build vast, beautiful structures. Galaxies are not solitary wanderers. They group into clusters and superclusters, connected by vast cosmic filaments. These structures form a cosmic web that maps out the large-scale structure of the universe. Our Milky Way is part of the local group, which includes the Andromeda Galaxy and about 54 other smaller galaxies. Observations of galaxy rotations revealed that visible matter alone couldn't account for the observed gravitational effects. This led to the hypothesis of dark matter, an invisible substance that makes up about 27% of the universe. Dark matter doesn't interact with light, making it invisible to telescopes, but its gravitational effects are essential for galaxy formation. While dark matter holds galaxies together, dark energy is responsible for the accelerating expansion of the universe. It's a mysterious form of energy that permeates all of space and drives the universe apart. The discovery of dark energy was one of the biggest surprises in modern cosmology. In 1998, 2 teams of astronomers studying distant Type Ia supernovae found that these exploding stars were dimmer than expected, indicating that the expansion of the universe was speeding up. This was contrary to the prevailing belief that the expansion should be slowing down due to gravity. The nature of dark energy. Dark energy makes up about 68% of the universe, but its nature remains one of the biggest mysteries in science. Some theories suggest it might be a property of space itself, while others propose exotic new forms of energy fields. Interesting facts. Discovery of dark energy. The 2011 Nobel Prize in Physics was awarded to Saul Perlmutter, Brian P. Schmidt, and Adam G. Rees for their discovery of the accelerating expansion of the universe through observations of distant supernova. Cosmic acceleration. The universe's acceleration means that in the distant future, galaxies outside our local group will move so far away that they will be unobservable, effectively isolating our galaxy in a vast, dark cosmos. The future of the universe. What does the future hold for our universe? While we can't predict everything, scientists have developed several scenarios based on our current understanding of dark matter and dark energy. The most widely accepted scenario is the Big Freeze. In this scenario, the universe continues to expand forever, cooling as it goes. Stars will eventually exhaust their nuclear fuel and fade away. New stars will form less frequently, and the universe will grow darker and colder. Over incredibly long timescales, even black holes will evaporate due to Hawking radiation, leaving behind a dark, empty universe. The Big Crunch. In the Big Crunch scenario, the expansion of the universe might one day reverse if the density of the universe is high enough. Gravity would eventually halt the expansion and pull everything back together, collapsing the universe into a hot, dense state similar to the conditions at the Big Bang. This could potentially lead to a new Big Bang and the birth of a new universe. A more dramatic scenario is the Big Rip. In this model, dark energy's repulsive force becomes so strong that it eventually overcomes all other forces, including gravity and even the forces holding atoms together. In the final moments, galaxies, stars, planets, and even atoms would be torn apart. Interesting facts. The Big Freeze is often described as the heat death of the universe. While it sounds grim, it's a slow process that will take many trillions of years. Even after stars burn out, brown dwarfs, white dwarfs, and neutron stars will still emit faint heat and light for an incredibly long time. The Big Crunch theory suggests that the universe might be cyclical, with each Big Bang followed by a Big Crunch leading to another Big Bang. This eternal cycle would mean that the universe is constantly being reborn. And there you have it, folks. The Big Bang Theory and the origins of the universe, from the initial singularity to the possible fates of the cosmos. It's a journey that spans billions of years and countless galaxies, revealing the incredible story of how everything we know came to be. If you enjoyed this video, make sure to hit that like button and subscribe to Zain Facts Channel for more cosmic adventures. Let us know in the comments what part of the universe you'd like to explore next. Until next time, keep looking up and stay curious.